All right. Okay, so 10.5 is essentially permutations and combinations in conjunction with probability. All right, so what does that mean? Well, that means we're going to use these counting methods that we learned with the concepts of basic probability. So essentially what we're doing is we're taking 10.1, 10.2, and 10.3 and putting those together. All right, so look at what we got here. All right, we got, does anybody remember what's the difference between a permutation and a combination is? There's one main difference that should help you decide when you want to use one or the other. Does anybody remember what that was all about?
Take out the repeats.
Well, that was one factor of permutations, but that's not the difference between a combination and a permutation. It has to do with order, like things like passwords and phone numbers and anything that where order is important, that is going to imprise using a permutation. Combinations are quite different. And combinations are when we pull out a group or a smaller group out of a larger group, and we're not concerned about the order. And I think the one that I used is, for example, if you've got a committee that you want, pull out 3 committee members from 20 from 20 members, and you want to pull out a committee of 3, and you're not worried about any kind of offices or them being in any particular pecking order, then it's a combination. If we have like runners in the race where there's first, second, and third place, or if it's something with prizes, first, second, and third prizes, or even if we're talking about with a committee, there's president, vice president, and secretary, then that is when we use permutations. So those things still hold here. Okay. But the repeats is a subcategory of permutations. And when we use those, the repeats thing, that's essentially where we have to divide out, very similar to combinations as far as the formula is concerned, but it's slightly different. And that is set of what we divide out is the number of times something in particular repeats. So you're thinking around along the right lines, but like I said, the main difference is order. All right. So let's go ahead and start looking at this. All right. As I said, we can now use permutations or combinations, and we can also use the counting principle together with our probabilities. Now, here's something that's very similar to things that very simple, and they're kind of things right out of ALEKS. But let's just say we've got 7 people in a class: Jim, June, Javier, Jane, Jorge, and Jasper, and Jules. So we got 7 people. And we want to find the probability if we select 3 of them that they will be picked in that order of June, Jane, and Javier. All right. Well, this is order. Okay, now remember, permutations has a specific formula for it. Do y'all remember what it is? I'm going to put it in there. Remind you. It's back up a little ways, but I'm going to put it here. And sometimes people write it a little bit differently, but here's one that looks just like ours that we use. All right, so there's the permutations formula. Now, we're only worried about that one order. So essentially what we're going to do is we're going to do this. Maybe I ought to write it on the board, but it's going to be hard to type that in. So we just concerned about order. So there's only one way those are going to be able to appear. Now let's just say this. So the N was 3. I'm sorry, it was 7. And then the R is 3. Because we're picking 3 out of the 7. So now what we're going to do is we're going to do this. Okay. So does everybody see what we, how we coming up with that? Because we want to have that one order where there's, I'm going to go back over and look at it. We need to have June, Jane, and Javier in that order. So those 3 things are locked in. There's only one way to do it. Okay. So 1 over the total number of ways we can pull 3 from 7. All right. Permutations. 3 from 7 can be pulled. The total number of ways on the bottom. And then the one that we want is that one order of June, Jane, and Javier. All right, so we're just going to work this out. Down here. And let's just kind of calculate this on the side. And usually in ALEKS, they give you that little calculator to do this. So you can always use that, but I'm going to do it by hand here. And like I said, since I'm trying to go slow, it'll make sense to do it this way. And some people always like doing it by hand anyway. So I'm going to calculate this denominator over here. And that was the one that I just wrote over there. I mean, just copied and pasted in the notes. So the numerator is the factorial of that large number, 7, and the denominator is the difference. So 7 minus 3 is 4 factorial. And then using what I had showed you before, you can do this pretty quickly by just counting down here until you get to the 1 in the denominator. And then using the fact that anything divided by itself is 1. So that's 30 times 7. So that's 210, I believe. Double check that for me. I'm going to do it with a calculator here on just to make sure.
Ten is correct.
Oops. $210. Okay. So there's a 1 over 210 probability that we select those 3 from the 7 in that one order. All right, any questions about that? Like I said, we got plenty of time, so. All right. Okay, now the next thing is part B. It says, and it's 3 other people, but the important thing is 3. Jules, Jorge, and Jasper will be picked if order does not matter. All right. So let's see if I can find one real quick. Rather than scroll back up and show it to you, I'll get one that looks like ours. All right. So slightly different. The C on the left is basically just to show you that we're talking about combination. So the formula is slightly different in that in the denominator, you get an extra R factorial down there. So really what happens is, in the big picture of things, you take the number of permutations and then you divide it by whatever R factorial is. In this case, R factorial is 3, which is going to be 6. Well, let's go ahead and just calculate it out. All right. So now, so what we're going to do, we're going to simply find and we're going to go through that same process. Now, let's go ahead and set it up. So the N and the R are the same things. So we're going to use that formula. So we're going to, let's just do it over here separately, and then I'll come back once I get the number and put it underneath. So 7 factorial still goes in the top. We got the extra R factorial. I'm sorry, it's a 3 factorial, which is OR. And then we still got the 3 minus 7. I'm sorry, 7 minus 3. Factorial. So that's and then 4 factorial. So hopefully you can see that the only thing that's really different is that this one's going to have an extra 3 factorial down there. Now 3 factorial is 3 times 2 times 1, which is 6. We could just take 210 and divide by 6, but I'm going to take it the long way just to show you. Because you may not always do this one first, but you can do that real easy by just finding out what the 3 factorial is in this case, or whatever your factorial is for that R, and dividing your permutations by that. So that's going to be same thing. Oops. So I'm going down to 4 factorial because that's the largest one. It is possible for the R to be larger than this one, but usually it's the second one that is, so that's why I go down to that one. So then what I'm left with is 7. And then it's 3 times 2 times 1. Now the 1 really doesn't add anything because it's 3 times 2 is 6, 6 times 1 is 6. So the easiest way is just to strike out the 6, because this is 6 and that's 6, so we got 35. So as I said is, if you would have taken 210 and divided by 6, you would still get 35. So you might want to remember that, because I do believe when you get these, they give them to you, both of them together like this. So like I said, it could save you some work. All right, any questions about either one of those? We got plenty of time, so don't be afraid to pipe up. Y'all are awful quiet than usual, so usually y'all got plenty of questions, and I can kind of understand why, because here we are, they got this half week, and plus we had off Thursday, so you know there's a tendency to want to keep taking off. I know my body feels like.
The only problem I keep running into is the actual English in the Alexis system. I switch them up all the time.
Well, you mean the way that they say order or no order?
Yeah.
Well,
they use a sort of tricky language on purpose, and I'm pretty good at English.
that might be the case, and I can't remember anything specific, but you know, they might just imply it. Like if we were to say, we could put this another way. Let's just say for the first one, they could say, if we want to pick these 3 people and have them be president, vice president, and secretary, they wouldn't need to say order, but order would be implied, because if you're picking them out for a specific purpose, then there's only one way that they can be put. Whereas with the combinations, if you're saying we're just pulling out 3 people for a committee, and those are the ones that usually people have trouble with, is one where they mention committee, is they'll just say pick out 3 members for the committee. And if there's nothing in there that implies order, or if it doesn't say order, then you know you go into combinations. But if there's something in there that says order, or If it implies that they're going to be doing a specific task, then the order will also apply in its permutations. That's probably about the most succinct way I could put it, because just over the years, I've just seen that that's the one thing that hangs people up, is just when is it order and when is it not order? Because they don't always tell you order. They'll just sometimes imply the order, because when you're pulling out 3 people and saying they're going into these slots, like for example, there's one I'm thinking of now. Let's say there's 20 people at a party. You're pulling out 5 that are going to get a door prize. And they could say something like 5 that are going to get a door prize all the same. Or they could say something like 5 that are going to get a potted plant as a door prize. But if you wanted to imply order, you could say 5 are going to be pulled out to get prizes 1 through 5. You know, they're not the same. They're not equal. So like I said, yes, there are different ways of doing it, but just if order or rank or distinction is implied, then it's permutations. Because like I said, yes, sometimes, like I said, I know that that's what they'll do. They won't come out and use the word order, but they'll give you a scenario where order is what has to be used, because that's the only way you could get people into 3, you know, like you're going to give them a gold, silver, and a bronze medal. You know, those are not equal. They're ordered. So just pay attention to that. The reason that they're being pulled out, is it for something that you can't distinguish between them? Or is it something where there is a distinction between each one of the ones being pulled out? Like I said, this one was pretty much just, it just said order, no order. So that one's kind of easier. I'm going to try to get to one a little bit later, because one of the things that like combinations is the idea of a lottery, because most people that play the lottery know this. But when you pick your numbers, you don't have to pull them in any specific order. It's just that you've got that bag of numbers, you know, in other words, whether it's pick 5 or pick 6 or whatever, as long as you've got those numbers in some order, then you're a winner. But that's called combinations. If you had to pick them, or if you had to match them in the order that they pick them, you know, out of the little popcorn machine thing, then it'd be a lot harder to win, and probably nobody, you know, it wouldn't be people, you know, it would discourage people from wanting to play. So combinations is probably the most common type of the lottery is probably the most common type of combinations usage that we have in at least, you know, local kind of examples. All right, let's see what else we can get into. All right, so here's another example now, and then we'll kind of answer that question as we go about whether order is important. The club consists of 5 men and 7 women. 3 members are selected at random to attend the conference. Find the probability that the selected group consists of 3 men. So first of all, let's just kind of answer, how many total people are there in this club? 5 and 7. So there's 12 people in the club, correct? 12 members, and that's what that shows you up here. Now, we're just pulling 3 people out to go to this conference, and is order important in these 3 that are being picked out? Y'all see anything that implies order?
If it's permutation, then it does require the order.
Okay, where do you see permutations at?
No, I said if it had it, so it doesn't, so that means no, it doesn't have to be in order.
All right, so it's just 3 people that are going. You're not sending in, a one person to be in charge, the second person's gonna carry the money, and the third person's just coming along for the ride. There's nothing implied like that. It's just 3 people. They're gonna go, all expense paid, maybe. That's kind of how we have conferences like that. Somebody gets picked to go. And usually like the book publisher will pay for it. Kind of thing. All right. So I've got it kind of already set up in a very basic way, but we'll go through the actual calculations for it. But order of selections does not matter. So this is a problem involving combinations, okay?
So I was right.
You're right.
Order doesn't matter. Okay.
Yeah. All right, hold on 1 second. Oops. I want to do something. I just thought of something that I could fix on this to make it a little bit better. All right. All right, so let's go through the process of actually setting this up. I wanted to get something out of the textbook, and the thing just doesn't stay open very long if you don't do anything. It's kind of aggravating, but hold on 1 second. All right, got it back open. I just wanted to have this as a kind of a backup problem for later on. And I noticed that it just logged out. All right, let me find it again. I don't know if we'll get to this, but I got one that's like it, but I wanted to, if we had plenty of time, I would want to go through it as a second. All right. All right, so we got 12 members we're picking from. And you got to think of it, we're doing this blindly, all right? We're not doing it with any kind of favoritism for the denominator, at least, because you got to think about this. You're taking 3 and you're pulling out at random. So that means there's combinations of 3 out of the 12 ways that this could be done. All right, so let's put this over here. order is not important, so we are going to use combinations. Now, what we're going to do, I'm going to type it out. So that's the numerator, and then in the denominator, it's okay. So that's essentially what we got to do. All right. Generally speaking, I always try to go for the jugular first, which when I say that, I'm just trying to be funny because the big number, the denominator, is the one that I like to look at first, because once you slay that beast, then it makes it easier to see what it is you're going to put in the numerator. All right, so remember, we're doing combinations. And we're picking 3. And we're picking from a group of 12. So that's the total number of ways we can pick 3. Because we could go in there and pick 3 women. That's certainly possible. But that's a way that we've got to count if we're going to do the probability right. So like I said, there's an awful lot of ways to pick 3 out of 12. And as far as I know, if you tried to do something where you could actually see this sample space, like create a tree or, write them all out in some kind of way, it's going to be really, really complicated and very hard to do. So what's important, though, is just how many ways can we pull 3 out of 12? And that's our denominator. But what we want in order to be successful at this, we've got to pick 3 men all right, we got to have 3 men. Now, what's going to be the large number? Go back over here and look. What do you think the large number is going to be for that numerator? What are we picking from? What do we have to get our 3 men from? There's 7 women, so how many men are there in this group? Well, there's 5. So as long as we get the 3 from those 5, then that's fine. Okay? So any of those outcomes will be fine. As long as we get 3 out of those 5, then we got winners, because they will be 3 men. So that's essentially what we're doing right here. All right, any questions about the way we're setting that up? Okay, does that make sense? All right, like I said, I got plenty of time here, so I want to make sure we understand this, because like I said, can be a little bit complicated. All right, now that number in the denominator is going to be the larger number because we're pulling 3 out of 12, and then as per the rules of probability, the smaller number is going to be on the top because we're pulling 3 out of 5, so that's going to be smaller. So just remember, the way you set these things up is important. That larger number is always in the denominator. Okay. So now let's just go ahead and calculate it out. I'm going to do it by hand. As I had said, if you've got the the ALEKS up and you got a problem like this, you can use that little calculator they got. And that's one of the good things about doing the tests in ALEKS, is because you got that little calculator. Because it's got the one in there for permutations and combinations, and they also got the factorials, and so that can save you a little bit of work. But I'm going to do them by hand because I like to be able to show you how to do that. That it's really not that bad doing it by hand. All right, so it's just going to be double duty. I'm going to just do them off to the side, and then once I get the numbers, I'm going to pop them into place. Let me get this ready here. All right, so let's just put it over here. So I want to put here, we're going to do the, generally speaking, I always do the denominator first. It's the larger one, so let's do that. So 3 minus 12 is 9. And then we got the extra 3 factorial there. And as I said, usually this is not as hard as it seems to be. And sometimes finding it on the calculator is harder. Especially like in my Math 203 class, we do the same stuff. And the graphing calculator is what we use there. And these things are buried. You got to remember where they're at. And every time I go and use them, I mean, I every semester, I always have to remember, where are these things at? So that's all that's left in the numerator, 12 times 11 times 10. And down here is 3 times 2 times 1. So that's 6. Like I said, you could do this any number of ways. 2 goes into 10 5 times. 3 goes into 12 4 times. So now these are all 1 down there. So what is 4 times 11 times 5? So that's 44 times 5. So 220. So our big number Goes down there. All right, any questions about that? We okay on that? All right, so that's the denominator. So the numerator, so 5 minus 3 is 2 factorial. And then you got your extra 3 factorial down there. And as I said, every once in a while, you'll have one where the larger number is on the left at the denominator, but it doesn't matter. You still want to, it's a good idea to take out the largest one, or that's the quickest thing to do. It'll work out if you do it either way. So 3 factorial over 3 factorial is 1. And then 2 factorial is just 2 times 1, so that's just 2. So that's 2 goes into 4 twice, and 5 times 2 is 10. That's not a good 10. And always simplify your fractions down. Pay attention to what you're asked to write it to. If it's fraction, then it's a simplified fraction. Always. So 1 over 22. If it says, write as a decimal, something like this, it would have to tell you what to round to, because 1 over 22 is a repeating decimal. It's like 0.0454545, and it repeats. So you'd have to have information on where to round it off to if you round it off. You can't just round it off unless you're told to do, because it's once you round off a repeating decimal, it's an approximation. So you have to be told where to approximate it. All right, any questions about this? Don't be afraid to say anything. All right. Okay, let's look something else now. If you got no questions about that. All right, so most people are familiar with this kind of lot. If you ever went to high school, and they might have done away with locks now. I don't know. Maybe they're built into lockers. I'm not sure, but at least when he was in the locker room, you'd have a master lock, and this right here, technically, it's what we call a permutation lock if we were being mathematically correct. Most people call it a combination lock, but the reason why it's not a combination lock is because the order in which you put the numbers in is important. All right. So if your combination is 1, 2, 3, you can't put in 3, 2, 1. You can't put in 2, 1, 3. Only 1, 2, 3 would be a working combination that gets it open. the order is important. So, like I said, sometimes things in real life are what ends up confusing us because they're just misnomers. And like I said, this is a misnomer, calling this a combination lock. It's actually a permutation lock because the order is important. It's like a phone number. It's like a password. The order in which you put in your characters is important, or numbers in this case. All right, so let's say a thief has time for 10 tries at opening the above lock. What is the probability he could open it in those 10 tries? How would you think you might handle this? All right, so let's try to find out what our numbers are that we're going to be working with. Now, the first thing that we've established here is its permutations, okay? So, one number out of all of the possibles is going to open this thing up. So, first of all, what is, and I'm just going to put this, I probably should have put this, but it might have been. Okay. So what we got to pull out is three numbers. Okay.
Excuse me, Mr. Cruz. Is it possible I can leave? I'm pulling up to my.
That's up to you. I mean, I'm not gonna chain anybody in here. I already called roll, so. All right. So we're going to be pulling three, and this is the thing. It's kind of it's implied in the picture. How many are you pulling from? How many choices do you have for your three numbers, or your three number combination, three number permutation? How many choices? You sure about that? Here's the thing is, okay, that you're right that it goes up to 39. But what about?
I'm sorry, my phone had got disconnected.
Okay.
Did you say it was okay?
Yeah, that's fine. Just
okay. Thank
this
you.
is going to be on Canvas. All right, so we got to count that 0. So how many are there? We did 39.
40.
40, okay. You got to watch that. It's like the same thing when we looked at those license plates. It's 0 through 9, but that's actually 10, okay? Because the 0, even though generally when we're counting, we don't count 0. But in this case, it essentially is the same thing as a 10. And this is one of the reasons why, when, like we just have this, controversy I heard on the radio is this whether 20 completes, 2020 completes the decade or not. And it's not really a controversy when you're counting because you don't count the year 0 because you don't get one full year until you get to, 2011, one whole year. But when we're counting discretely and the number here, there are 40 numbers to pick from. It's a little bit different because one thing is like time is continuous. These are discrete. You can't pick anything in between. All right. So let's go to put here. Okay. Oops. Well, that's a 40. Let's see if I can do a little bit better job on both of those. All right. Well, that's a 3. All right. So let's just do the denominator first. And this is why usually these things are real easy to do by hand. There might be some that are not, but since we're just subtracting 3 from 40, it ends up being 37 factorial. So 40. Okay, so these are gone. That's just 1 there. So we're left with
Should be 59,280.
all right. I'm gonna just type it out. So, and then I don't doubt you. I'm gonna check it. Just all right. $59,000. You're right on there, Captain. All right. So that's our denominator. All right. So your number, Captain, is going to be down here on the bottom. All right. Now let's just kind of think about this. Before we get to our final answer. Now, if we were just doing one try on this, it would be 1 out of 59,280, right? Does that make sense? Because we figured out that denominator, because that's how many different combinations there are, permutations there are. Or there's 59,280 unique one. I have to keep using the word combination, so it's kind of messing things up. But there's 59,280 permutations possible. Okay, so if you had, in theory, that many people, you have to start repeating them after a while. All right, after 59,280 are used, you're gonna have to repeat them. Now, so the one try is 1 over 59,280. So if we wanted to do it 10 times, you kind of look at it like this. I'm not going to write out all 10 of them, but what's going to happen here?
Just drop the zeros.
What's that?
Just drop the zeros.
I'm not sure what you're saying. If I add up 10 of these, how many are there going to be in of these 59,280 things? So imagine there's 10 of these with a 1 in the numerator. Then when I add up all of those 10, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So yeah, in this sense, maybe you were looking ahead to this about dropping the zeros. But I just kind of wanted to show what happened in between. Or you say the probability, you could say 10 times 1 over 59,000. Same thing. That's why we got multiplication. So sometimes if you're adding the same thing 10 times, well, it's easier to say 10 times. All right, so 10. And what you said, Catherine, well, we're going to just drop the zeros, because if you simplify this and divide both sides, top and bottom, by 10, you got 1 over 5,000. 928. Oops. So by doing it 10 times, then assuming you're able to keep track of them, you only got to do this 5,928 times to be sure you got it. Okay. So you can kind of see maybe why at one time, I mean, and they may still, I think they still use these kind of locks, but that was a pretty solid way for many years. And probably, like I said, they probably still use them to a certain extent, because you've got a pretty hefty number of ways that thing can be open. So it's pretty secure. All right. Any questions? We got one more we're going to look at. All right. So the next one is going to involve using it's going to use two factors. It's going to use the combinations, and it'll also use the counting principle, because we got to already use the counting principle to a certain extent, but we're going to use it now in conjunction with combinations. Hold on a second. Let me something here so I don't forget to do it. Oh, that's right. If you have any questions, all right. So let's go back over to the notes. All right. The probability of winning the Powerball lottery. Now, I don't know how realistic this is because I don't keep up with the amount of numbers, but that are repicked from. But one of the things that you'll notice, and I've talked to people about, like for the way the Powerball works, as I understand it, is you've got 5 numbers that you pick on the state lottery, and then the Powerball is a separate one that those states that participate, then that goes along in determining who the winner is of the big prize. So you can win the state lottery separately. And in this case, we're going to assume that the number that the numbers that we have to pick from is 1 through 69. Like I said, I don't know if that's realistic, but like I said, I don't keep up with it, but it will change, I'm sure, depending on whether the state lottery commission is hard up for funds or if they're being more generous. They might lower the number of numbers available at certain times, but more likely they're probably going to raise them up. And then the Powerball is 1 through 26. Well, let's look at this, how this works. All right. You can go through this pretty quick, and we can go through it if you really want to see the specifics, but it's just a plain old combinations on one side. But anyway, for the state lottery thing, you're essentially picking, I don't want to write over there because it's not quite fit. Something's fishy about that. I never noticed that. I'm just going to say state lottery. Okay, it's 1 through 69, a choice, and you got to pick 5. So to save time, I'm going to just pop these out. Oops. It's not permutation, it's combinations. Sorry. All of a sudden, I'm noticing what time it is. I thought for sure I was going to have plenty of time to just slow down. And I do. I just had in my head that I was going to have a hard time filling up the class time today. I was wanting it to actually be a little bit short since it's a short week, but oops, that's 64. All right. So if you calculate that out, that ends up being 11,238,000 and 513. So basically, it's probability, and I can't remember what this population Louisiana is. I think it's like 7 million. So you got just a little bit more than maybe like 1.5 times the number of people in the state, okay, of winning this. That's how many different numbers there are to pick from. All right, so this is the number of ways to do the state lottery. Now, here's the number of ways to get your Powerball. Well, it's real trivial, but you're going to pick one out of 26. And if you were to go through and do that, hopefully you'll find out there's just 26 different ways to do that. Oops. Now we use the counting principle. And if you do that, I'm going to do it off to the side here and then write it on there. So 11,238,513 is 29,220,133,8. And then I'm going to put the commas in here. So there's 292,201,338 ways to win the Powerball. So with one ticket, it's going to be just going to be 1 over that. And then same thing that we did in the problem with the lot. Every time you buy another ticket, it would just raise the numerator by that amount. So, if you did 10 tickets, then, you'd have a 10 over the top numerator. All right. So